The whole premise, whenever I was working with the Bureau of Forestry and with my company, Biomass Renewable Energy, the whole premise was what I have written here, to establish these decentralized small thermal energy, woody biomass energy systems throughout the community, help our local communities with some economic development. And we do this by utilizing woody biomass number of feedstocks, things that we call low-value timber or low-use wood, mill residue, short rotation woody crops. We're seeing some of that getting a foothold, the short rotation woody crops. We're seeing that starting to come online in Pennsylvania as well. How's my volume? Am I getting across through the microphone?
Online attendees, can you hear the speaker?
Yes, it's good.
Okay.
Good, very good. And briefly, I'm going to assume that with this program, everyone has a little background on biomass energy. If not, just very quickly, why does biomass energy work? Why are we pursuing these installations? It saves money. You know, of course, wood chips are traditionally have been a little cheap, less expensive than some of the fossil fuels. And when dealing with wood chips, either off the head saw at a sawmill or whole tree chipping right from the woods, we're dealing with a locally produced feedstock. That's good for the economy, local economies. Generally, that revenue generated stays within the local community. And of course, trees, we can always grow trees, so it's a renewable, sustainable resource, especially if we follow the best management practices, some of which I'm going to talk about here in a little bit. So it's sustainable. We can always grow a tree. You can't grow another gallon of oil. We utilize wood waste, or what we prefer, wood residue coming off the head saw. And these, burning biomass, it's always going to be a small component of our total energy systems out there in our buildings and businesses. But it represents a diversity in our energy portfolio, and that's good for security, national security. Used to be, we'd hear energy independence. We want to get off oil, get off coal. I don't believe we're ever going to completely replace fossil fuels or other types of fuels for energy, but not completely, but it acts as a diversity. And it's that diversity that we gain national security. Carbon neutrality, there's the concept or the argument of the notion that what carbon dioxide you take out of the atmosphere to grow a tree, when you burn it, you release that carbon dioxide to be used again to grow more trees. So it's an argument that has some merit. There are other benefits to the environment and to wildlife habitat. I mentioned local economy. There's one Northeast study I wanted to throw this in that this came out of a slide that a friend in Maryland shared with me. For every dollar spent on fuel oil for heating, only about 2% of that revenue remains in the local economy, unlike the hardworking foresters and loggers out there and truck drivers that prepare, and deliver that wood chip to a school or a hospital or a greenhouse. So a little more of that revenue stays locally. Pennsylvania, very rich natural resource base. We grow some very fine hardwood trees for lumber. During the milling process, you see the head saw. It's an Amish mill. You cut the slab off the log, you square up a cant, you make boards out of that. There is surprisingly a large amount of wood that can be chipped and used for fuel. And predominantly our schools, hospitals, the greenhouses right now are utilizing the chips that they get delivered to them. It's the slab wood that gets chipped at the mill. Predominantly, that's what's supplying our existing biomass energy, wood energy boilers. The bottom left, you see a picture of a harvester. Even trees that aren't that saw timber size, we still remove them with the objective of improving, doing a and improvement thinning within our forests, we can still utilize that. We used to cut them and chip it for pulp and paper industry, the paper industry, but we're not a paper producing state anymore. We used to have 7 mills, paper mills in Pennsylvania, and we're down to 3 right now. One of those, all of its feedstock comes out of South America, eucalyptus, shipped in through Baltimore, Philadelphia, Baltimore, I think. So even they're making paper, Charmin toilet paper out of eucalyptus fiber because of its consistent fiber length. So we're really not producing that much paper as we were. What do we do with all this low-value timber, low-use wood? Using it as a feedstock for boilers is a good option. Here we see there's a chipping operation right on the landing. They do whole tree chipping, and flail debarker knocks the bark off so they can get a cleaner chip. And that is a good viable alternative for wood fuel for a boiler. Down here in the bottom left, a lot of materials made into finer grades of wood chips, even sawdust for the pellet industry. That's a picture of Energex, southeast of here. So very viable. The pellet industry is very, very viable in Pennsylvania. And then, of course, there's a picture of our short rotation woody crops. That picture on the right, I took Montour Preserve, one of the coal-fired power plants. We have a little study put in these hybrid willows. And the day, that was around right before Mother's Day, and those trees were just loaded with bees, and they were just intoxicated with their work that they were doing. You could go up and just push that bee right off the floret, and it didn't care being touched. It would just crawl back on, keep working away, gathering pollen. Interesting what happens on, and that's a good study, I think, good potential study, what's happening with that kind of biomass bee cultures during the flowering season. Talking about sustainable forestry, best management practices. Well, we always hear that argument, oh, we shouldn't be, and I hear it especially down in coal country, the southwestern part of Pennsylvania. We shouldn't be cutting trees for fuel. Go to natural gas, go to keep burning coal. But we can manage our forests so that we maintain that renewable and sustainable growth. So the best management practices, things that we should do, promote regeneration and renew our forests, protect the residual stand. So everything we do, we should look, whatever we manipulate, however we cut our stands of timber, we should always look at what is left, what residual stand is left, promote it, and follow those cutting practices that will actually lead to renewing and regenerating that stand. We want to maintain or increase our species diversity in all of our cutting practices. Of course, protect soils and water resources. Our Bureau of Forestry #1 objective, whenever you read our mission statement, is to protect clean waterways and our water resources in the Commonwealth. And then, of course, improve and maintain wildlife habitat. How do we do that? Very quickly, silviculture in one slide here. How do we do that to establish, sustain new forests? Follow the acronym CDL, control competing vegetation. You see the bottom left, a lot of fern. This is fern, New York hay-scented fern. Some very challenging issues and problems with fern coming in and keeping natural regeneration from becoming established in our forests. So, you're going to see our last slide here on the bottom right. It's all about light manipulation. If you open up the stand too much, cut too many trees at once, you'll encourage these invasive species like fern, autumn olive, striped maple. Even mountain laurel can be a form of competing vegetation that shades the forest floor, keeps natural regeneration from becoming well established. The middle slide there, reduced deer impacts. Deer, overbrowsing from deer has been a very big problem. Uh, 15 years ago, I'd say, we embarked on a program of increasing, a little longer than 15 years even, a program of increasing the harvest, the annual harvest of deer by issuing more licenses, and even especially for those management areas where deer were overpopulated and overbrowsing. So we took measures in state game land and state forest land, public lands, to increase the harvest, and it was successful. I mean, you get the deer population down to a lower level that allows the regeneration to come in. You can do a lot to sustain regeneration and regrow our forests through decreasing deer impacts, overbrowsing impacts. And then at the bottom, the third note there, consider light requirements of the species you're trying to regenerate. The harvesting, doing improvement thinnings or regeneration type thinnings in our forests, it's all about light manipulation, how you can increase the light and increase the soil temperature so that the species that you want, the particular regeneration hardwood species that you want in that stand, the light requirements are met to establish that particular species. I said that if you cut too hard, striped maple will come in, and that's what you'll be growing. Red maple is even an issue in some places. Right balance, achieve right density of trees in the overstory, provide just the right light and shade combination to allow regeneration to become firmly entrenched and of enough abundance, frequency and abundance to regenerate that stand. So the acronym CDL will help you remember that: competition, deer, and light requirements. Here's an example. It's right on the top of the ridges. If you're a hunter, if you like to hike, you've walked through these kinds of stands all over Pennsylvania, I'm sure. They're either hit with a number of problems, gypsy moth mortality, for instance, or overstock stands here at the bottom right, smaller diameter trees, a lot of them, too many of them per acre. What can we do to help rejuvenate these types of stands? One is several regeneration manipulations, regeneration cuts or harvests. One of them is a shelterwood, where you reduce the number of stems per acre, you increase the light that's coming through past the other crowns, tree crowns, increasing the light on the forest floor, and you're regenerating that stand. This happens to be black cherry. It's hard to see here, but there's a fence right in front of this stand to keep deer out. And this was very successfully regenerated. Just down here, you saw this. If you turn around, this is looking south. If you turn around and look north, you're looking at this. And, there's some oak growing 16, 18 inch. Doesn't look like it's the straightest and cleanest stems, out there. But I like this slide because this is what's typical up on our ridges. Slight crook, lots of old knots, lots of limbs. Not the best looking example of an oak tree, but it's typical, and a lot of good lumber to come out of this. And this was another situation where it was successfully regenerated. This is a shelterwood, heavy seeded oak drops, in that area. Squirrel have a big part to play in planting acorns. And whenever you disturb the soil through this type of heavy machinery that harvests the trees, drags the logs out, you disturb the soil, you get a lot of root sprouts, a lot of suckering, coppice growth, seedlings that come from the acorn that's dropped by these heavy seeded trees. So these types of shelterwood manipulations are successful in helping to regenerate the stand. And that's what we're after. We have carpet regeneration. You leave these residuals behind to help shade and provide seed. Now what we can do is go in and remove that residual stem all that those residual trees, full direct sunlight on a well-established carpet of regeneration, that'll just take off and establish the next stand. In 3, 4, 5 years from now, that'll be well over your head, and it'll be hard to walk through all that regeneration. So that's what we're doing with forestry practices, best management practices to regenerate our forests, eventually to provide fuel for these boilers. Moving on here to wood energy projects. Paid by these projects that were paid by the avoided fuel costs compared to fossil fuels. If wood chips cost $40, then you would be paying 80 cents a gallon for number 2 fuel oil, or 50 cents a gallon for propane. And these good projects take about 5-10 year payback. That's good. That's a good payback period. But you can see if at $40, and that's typical of what we're paying, what schools and hospitals are paying right now for wood chips in that neighborhood. You can see that you'd have to buy pretty cheap oil to match the cost of a ton of wood. Here's some examples. This is taken from 2014 or 2013, 2014. Some schools there that had in a greenhouse that had been using oil. Northern Bedford School District, right off the bat, the first couple of years, they were saving $375,000 a year. This is back when oil prices were a little higher than they are now, but just a good example of what motivated the schools to look at this. Mountain View School, they're, I think, the oldest installation, wood boiler installation in the state, and they were saving $130,000 a year. Dillon Floral, 190, Benton School District, a little less. They had started off, Ben had started off burning switchgrass briquettes, and turned out switchgrass is a little dirtier fuel, a lot of slagging issues. So they are burning wood pellets currently. And because pellets are a little more expensive than wood chips, they're not saving as much. But to dispel any rumors out there, Benton is not going to get rid of their boiler. They're happy burning wood pellets. Elk Regional, the hospital up in St. Mary's, was burning natural gas. They have currently shut their wood boiler off because of natural gas prices are so low. Prior to 2013, a number of years, they were enjoying, when oil prices were high, they were enjoying $300,000 a year in avoided fuel costs. But they're burning natural gas currently. So, and not only the hospital, but they've connected to the senior care facility right next door. And we'll see how long natural gas prices stay the way they are. But they have that diversity. They have that option of switching back to wood chips at a later date. Here's a case right here looking at a project from 2011, Penns Valley School. It's just east of here, just between Center Hall and Spring Mills. High school and an elementary school across the road from each other, over 250,000 square feet. Combination of oil and electric for heat and hot water. They were spending $610,000 a year. That was their fuel bill for both oil and electric. By putting in the boiler plant here on the right, they're saving about $250,000 a year. You can see the garage door open. That's where the truck backs in, dumps wood chips, and that wood receiving bin is kept separate from the rest of the boiler room. So it's a very clean operation. You can see the big windows there. Very nice, beautiful installation, ARE boiler. They keep the lights on. You can pull up at night and look in there and see the whole operation. So it's very nice installation. Payback period was about 5 years. I don't have any information on the grants that were used to help fund this, the incentive grants. we'll see that here, some of the examples in these other installations. Evangelical Community Hospital, to be fair, over in Lewisburg, they're at 350,000 square feet. They have a 500 horsepower steam boiler and AFS boiler manufactured in Lemoyne, right across the river from Harrisburg. It was a $5 million project. Their grants totaled $1.25 million. Fuel savings, about 600,000 plus. Short 6 to 8 year payback. But in this situation, and they switched back to oil. I think I'm mistaken. They switched back to that. They switched to natural gas. So I'll have to correct that. So keep that in mind. It's natural gas that they're using currently. And again, just like the Elk Regional Health Facility up in St. Mary's, burning gas. We'll see how long this trend lasts. Predictions are, some of these power plants that are coming online, there are 3 of them, I think, slated. The predictions I'm hearing, once they start using natural gas for other forms of energy production, that will change the scenario. We'll start seeing natural gas prices ratchet back up. Time will tell what happens there. Pennsylvania had 3 hospitals: Elk Regional, Evangelical Community Hospital, and then Warren State Hospital up in Warren. We had 3 hospitals that were using woody fuel to heat their buildings, and all 3 of those have now switched back to natural gas. Warren State Hospital, I understand too, is going to decommission their boiler, eliminated completely. That was a boiler installation installed back in the early 90s. So important to note, though, 3 boiler installations at 3 hospitals, and they've all gone to burning fossil fuel again. Evangelical Community Hospital, a nice takeaway here is they actually use their steam boiler through the summer to heat the water coming back, the air conditioning water coming back from the buildings. Take it up to the roof, get that entropy. When they bring it back down, they take it to an absorptive chiller and create air conditioning for the hospital in the summer months. And this hospital as well has a CHP system, a backup. So they've got combined heat and power and providing air conditioning as well. It's a nice setup. Crawford Central up in Meadville, one of the most recent installations. Crawford Central School District, their Career and Technical Center, and the Recreation Complex all combined through a joint operating agreement to install and operate a combined heat and power boiler system. $3.5 million project. They were consuming $600,000 in electricity and natural gas fuel costs prior. Received a lot of grant money, almost $1 million in grants, and currently they're saving about $200,000 annually in avoided fuel costs. Very nice installation. A little more information here. They have a 8 million BTU output steam boiler. And they've got some thermal storage. They're hooked into a steam turbine. Maximum output is 190 kilowatts. It's a variable production. It depends on how much they're online with their steam system. But their max capacity there is 190. Unique to this installation too, and we're trying to encourage this as much as possible, is the use of thermal storage tanks. Here the turbine exhaust is captured the energy in thermal storage, and then that's used to distribute to the 3 buildings for heat and also domestic hot water. So we're going to, in the near future, we're going to promote the use of thermal storage when we can, because that increases the efficiency of the system. not all of our installations in Pennsylvania are using thermal storage. This is what the Crawford Central system looks like, hot water tank stored there. And on the right, it's a small, very neat, compact boiler. It's a Messersmith made in Michigan. And the Messersmith utilizes a Hearst boiler, which is manufactured in Georgia. So it's like I said, very compact, very a good, efficient system. And we have a number of these Messersmiths in our other school installations in Pennsylvania. And then how am I doing on time?
10 to 1, right?
10 to 1, okay. I'll just go through this last example very quickly. Sullivan County Area School, they received an AFS, another AFS manufactured in Lemoyne. This is an example too of hot water thermal storage, another installation, newer installation that's utilizing hot water thermal storage. Separate building, separate power plant right behind us. You know, we're taking a picture looking at the power plant. Right behind us is the school. And there's a picture of what the receiving bin looks like. They received a little over $1 million, 1.1 million in grants as well for a $1.65 million project. So that was very good for the school. And you'll notice in all these examples, all these installations here in recent years, they're all utilizing some kind of grant incentive, and of course low interest loans where they can get them. But one thing to be said about grants, yes, the grant is a good incentive to get a school board to get off the fence and make a decision and to move forward with a project, install a boiler. What I think is studying these case studies, what we find is that when it's just human nature, when the incentive is there, the price of the project naturally goes up. In the absence of these incentives, these projects are cheaper to put in. So, you know, we're using incentives to entice the school board, like I said, to make a decision, but they're really not helping cost-effective wise the costs of prices of these projects, because just magically the project cost goes up. Just something that we observed through these various installations over the last 15 years. They're 1.1 for a $1.6 million project. Shows the conveyor taking it to the front of the boiler. Again, just like the Messersmith, these AFS are very nice, compact, efficient boiler systems. Black box on the bottom is the combustion system, various ports for overfire, underfire air, and then the boiler tubes, water thermal mass is captured in the water tubes at the top of the boiler and then distributed. And that's what I have. Just one final note, just to give you a sense of perspective. We had 3 hospitals that were burning biomass, woody biomass. We had 4 greenhouses that are burning woody biomass that we know of in Pennsylvania, and about 14 schools. The hospitals are offline, and we have 1 school that has shut down. They're going to probably decommission if they have not already removed their boiler. It was an older boiler and was not the most efficient. But about 14 schools now in Pennsylvania continue to burn wood chips. We have a lot of other businesses like sawmill businesses that heat their facilities. They heat their dry kilns using wood chips because, you know, it's right there. That's what they have. We still promote those. We have 1 sawmill that's currently under construction that's putting in a a boiler, AFS boiler, that'll eventually heat dry kilns. So we still have some movement, positive movement with our wood energy installations in the state. The most recent was at West Branch area school district up above Phillipsburg, Clearfield County. Even in our lean times when we don't have as many of the incentives that we used to, we're still hopeful. We're still pushing to get more and more schools, hospitals, greenhouses, and other businesses to install wood chip boiler facilities. Any questions, any discussion here?
Thanks, Mike. Yeah, we're going to open it up to questions, and we'll let the students for this course go first, and then others as applicable. And just checking, is Veronica online? Veronica is one of the students in the course. I just wanted to see if she was online and interested in asking a question. But Mark or Jessica, do either of you have a question?
Why did the hospitals close down their systems and go back to natural gas?
Natural gas was cheaper.
Oh, it was still cheaper for them.
What we find, and this, I have no hard data to substantiate this, but when one of the hospitals was saving hundreds of thousands of dollars burning wood chips, a gas company will come in, they're losing that business, so they'll create a sweetheart deal, give them, and that's where I don't have hard data on this, but sweetheart deal might be to give them a much cheaper price on gas, or even if the gas is not that much cheaper, at least they lock them in on a fairly competitive price for a number of years. It's hard for the hospital to walk away from that offer. So
Right.
make you a deal you can't refuse, sort of thing.
I mean, that's interesting considering they just put all that money into installing the infrastructure. You think they would just...
Yeah, and that's, that was a 5 to 8 year payback period. They haven't operated that boiler enough to pay the boiler
Must have
off.
gotten a really good deal.
So they must have had a really good deal. Yeah.
Yeah. It's crazy.
And to the prices, oil prices, for instance, fluctuate so much, and that's one of the competitive advantages of wood chip fuel. Historically, it's fairly year to year, it's fairly stable, whereas oil, even throughout the year and from year to year, spikes up and down. You have a lot of variability, and we have had school business managers and school boards say, we're tired of that fluctuation. We want something more stable. Let's make the decision to put in a wood chip boiler. So that has been incentive for some of these installations.
Okay, thank you.
So one of the benefits that you mentioned was carbon neutrality. But I guess my question is it truly, considering the heavy machinery that has to cut the trees down, the transportation to haul it out of the location to someplace that can, either process it more to bag it or whatever happens to it, but there are other environmental costs that are in there. Is it just looking at tree growth to burning, or is it inclusive of the entire process?
That whole cost benefit analysis. I'm not an expert to speak on, all of what goes into the carbon neutrality argument, except to say that extra machinery cost, processing cost, the diesel fuel used to transport from the forest to the boiler, those types of data points are incorporated into that analysis. In defense of those who say that this is carbon neutral, the whole cost benefit analysis includes that type of heavy machinery costs. So it's not just looking at what the forest is growing versus what gets removed, or how many gallons of oil contribute so many tons of sulfur or carbon.
Thank you.
But there are those who oppose, they're opponents of the carbon neutrality argument, and it's so complex that I really am not equipped to adequately answer that. But I do feel confident to say that all of those other features are data points are incorporated into calculations.
Well, it's somewhat piggybacking on that question. From what you said, the previous closures of paper mills, as an example, forest and wood products in Pennsylvania are well-established markets, but right now there seems to be an excess, would you say, of wood available. In other words, low-quality wood is available.
Yes.
That can be used for energy production without threatening, the supply or the sustainability of the forest markets.
Yes, that is true, that we are producing more wood fiber in our Commonwealth forests than we are harvesting. We're actually increasing the number of acres of forest in Pennsylvania compared to one statistic, 1958 to now. 2008 was the statistic that the total acreage of forest has increased in Pennsylvania. Now, people will argue, but you look at these counties, Lancaster County for one, all the development, the loss of agriculture acreage. Look at the forests that are being converted to housing developments. How can you say that we're increasing our acreage? We're not. You have to take into account those areas, say in the northern tier counties of Pennsylvania, they were farms at one time, and they're coming back into forests because agriculture has dropped in its application in statewide. So a lot of those areas around Route 6, you drive through there and you see the fields are coming back into forest. So the net effect in the end is that we are increasing in our acreage, forested acreage. Utilization is better of the wood fiber that we harvest. There, at one time, it still goes on. So much of the trees or parts of the trees are left in the woods. That's not a bad thing because they rot and they replenish the soil. But utilization of the bole of the tree, the different parts of the tree has increased because of technology. So there have been a number of studies, $1 million study or billion ton study. How much are we harvesting? How much is growing? We have fairly reliable data on that. And one statistic, 600 million tons were being cut, 40 years ago, being processed, cut and processed. Early 2000, it was down to 200 million tons. And now that's about 300 we did a recent timber product output survey here in 2012 data. And we published that in 2014. That we were up to 350 million tons being processed. But then to throw that out on the table, some of that is other wood coming in from New York, Maryland,
Okay.
West Virginia. So, but that just gives you a ballpark on what we were cutting once upon a time,
Mm-hmm.
what we're cutting now, what we're utilizing now.
Okay. So is there anybody else online that would like to ask a question of Mike?
Yeah, this is Jack Barnett. I would love to.
Okay, go ahead.
Mike, I'm part of the Clean Energy Co-op and several nonprofit environmental groups in Northeast Pennsylvania up in Wayne County. And we've been trying to talk to various school boards around our area to get them into renewable energy and biomass. I think we've struggled because we keep getting the message, I think maybe incorrectly compared to your case studies, that pelletized furnaces are the way to go rather than just chipped. So could you give me a quick insight or maybe a reference offline I can look at to understand the difference between like briquettes, pellets, and just raw chips?
Well, why I would have to start by asking you a question. Why and who is telling you that it's better to burn pelletized or briquetted? That's the way to go versus just a wood chip. What's their reason for saying that, making that claim?
Well, I think my impression is it's because of the availability of good furnaces. But you may know better.
Yeah, I actually, and this is residential or for the schools, the small commercial?
Small commercial scale, yeah.
Okay. I would say that the availability of wood burning appliances, whether residential to large industrial, that there are an ample number of good appliances, boilers to handle wood chips, pellets, or briquettes. The smaller, say residential, light commercial boilers, in order to operate most effectively, need a drier chip. The boilers that are used in schools they're large enough that they can burn 45 to 55% moisture content wood chip. And actually, combustion engineers tell me they prefer the wetter fuel wood chip because in that size for a school, they feel they have better control of the combustion process when they have more moisture in that wood chip, as opposed to burning a kiln dried chip coming off of a furniture plant, where you get wood flour, fine sawdust, a little less control. You can burp the boiler, you can get micro explosions within the combustion chamber. So the engineers prefer that moister wood. Smaller boilers, smaller than light commercial, that wouldn't be smaller than what you would put into a high school, middle school. Those smaller boilers require moisture content below 35% and less. And that is a little hard to come by in the fuel supply stream, because few suppliers are actually preparing their wood so that they bring a 35% moisture content wood. What we say is, in those kinds of applications, it's good to get your wood and let it off gas, let it dry on it and season on its own, even as a pile of wood chips. Just let it sit for a couple weeks so that it dries out a little bit. So that might be where people are saying these smaller boilers, light commercial boilers, it's hard to find appliances that can burn a wood chip coming right off the landing or right off the head saw. Those chips tend to be a little too moist for those light commercial units. Now, residential, you go down to the very small. Yeah, you need a dry wood, a seasoned wood, to use in a large residential. Say you had a 3,000 square foot house, you wanted to put in a boiler. Those types of boilers require seasoned wood, and that's where it's very hard to find wood chips that are seasoned. So people opt for the kiln dried wood pellet, or even a briquette, where the supplier has control of trying to dry their fuel down. There are some in New England, some suppliers in New England who are doing that. They're offering wood chips that have been seasoned. They put them through a furnace and they dry them before they deliver them, because the wood chip is going to be a less expensive fuel than a pelletized fuel.
Thank you. I noticed Veronica has a chat question in the chat group.
Okay, and I'd like to come back to you, Jack, but we'll entertain Veronica's question now.
Seems to track it down here.
We're trying to
Go back.
get to your chat window, Veronica.
Bottom right.
Bottom right.
Please.
Well, for some reason, we're not seeing it here.
I can read it if that's helpful.
Sure.
If the financial incentives make projects more expensive, what do you think can be used as a mechanism to help biomass for energy adoption?
In the absence of the incentive? That's what you're asking?
I think that's what she means, yes.
Oh, okay, that's her question. What could be used instead of relying on financial incentives? The argument of carbon neutrality, the argument that we're promoting local business, the environmental benefits. Oil has sulfur in it, coal, a lot of sulfur dioxide, so it's a cleaner burning fuel. Frequently we'll get the question, well, we're doing a step backwards. We're burning wood. We're going to smoke out our communities. With the combustion controls that some larger boilers have, that's less of a problem. Many of these, you're never going to eliminate smoke completely, but many of these installations currently, when you visit them on a winter day, you'll see steam coming out of the stack. You won't see smoke. So, that's an incentive just to have a healthier environment, because you're burning wood and not coal or sulfurous oil. It's hard to beat natural gas. There's the argument, natural gas is such a clean fuel, should we be using it for thermal energy, or the argument I've heard is we should be producing electricity or developing it as a transportation fuel. So, the higher end uses. So, those are incentives. Those kinds of arguments are incentives for promoting the adoption of woody biomass energy.
Okay. Dan?
So, Mike, you mentioned maybe about 20 commercial scale facilities in Pennsylvania right now.
Mm-hmm.
What would you say is the ideal number that you think would be best for Pennsylvania, all told, given the size of the resource and the economic impact and all of those kinds of things? In a perfect Pennsylvania, how many of these facilities would be out there?
Well, I would look at the number of school districts that we have, about 502 school districts. Many of those are going to be in locations, populated areas where perhaps we don't have the footprint to maneuver trucks to come in, or we have too many residential areas, there are too many areas that are confined by the residential surroundings. But those that are more rural in their location, I would say hundreds of these school districts in Pennsylvania could be converted to woody biomass energy systems. So, what is ideal? Hundreds of school districts, hundreds of hospitals, let's say dozens of greenhouses, those kinds of installations. There are hundreds of sawmills. I don't have a firm number on it, but this is what I'm told by the forest products associations. Hundreds of sawmills that are currently using biomass systems. So yeah, what's the ideal number? It would be in the hundreds, low thousands.
So that sounds like a real opportunity for renewable energy project development.
There is, and then industry too. You look at not just wood, but industries that could utilize more woody biomass or forms of biomass. Chocolate factories in Pennsylvania. How many of them are available and supplying companies like Hershey Foods with cocoa shells? Those types of fuels could be increasingly developed. Peach pits, olive pits, those types of cocoa shells, those types of renewable organic residue from the industries could be developed, and we honestly haven't even looked at those.
My other question relates to how you talked about there's a need for forest management and a potential to harvest more material out of the forest in a way that actually improves the forest quality. But there's, I think, a lot of concern in the general public about overharvest and long-term damage to the forest. So what's the best way for a person developing a project like this to ensure that their forest is going to contribute, or their project is going to contribute to a positive impact on the forest rather than a negative impact?
Groups like us, the Pennsylvania Biomass Energy Association, the Fuels for Schools Working Group, the Pennsylvania Statewide Wood Energy Team, groups such as ours throughout the Commonwealth need to be proactive in school districts, hospitals, end users that want to consider woody biomass heating systems need to collaborate with us, with our Bureau of Forestry and our Pennsylvania Game Commission to inquire. We're here, we want to put in a biomass boiler. Where are we going to find our woody biomass fuel? In the expert opinion of the Bureau of Forestry staff, is there enough timber being harvested in our local surrounds, what acreage surrounds the county, that we are going to find ample fuel available to supply our boiler that we're going to install? That kind of conversation needs to exist. And so I would say contact the Bureau of Forestry, contact the service forester in your region, and get that dialogue going. There will be information on a number of sawmills in that county and surrounding counties there's information on those that have wood chips available. And so we as organizations, woody biomass organizations, and we who are working in the Commonwealth's Bureau of Forestry and Game Commission, we need to keep that dialogue open, keep looking for schools, letting schools know they can come to us for those kinds of answers. And there are fairly straightforward analysis that can be done by looking at available sawmills that have material. So we can answer those questions.
Okay, I think.
And I have a question for Jack. Are you aware, you said you're in Wayne County, and you've been talking to schools in Wayne County or surrounding counties, Jack?
Yeah, it's not recent. We did this before the natural gas boom, so it's not recent.
Because I know that there's a contingent of people in Wayne County, for instance, that were opposing the Marcellus gas developments, and they were interested in woody biomass boiler installations because they wanted to oppose Marcellus. Well, not because, but as an alternative to encouraging Marcellus gas developments. But my question to you is, are you aware of a workshop that the statewide wood energy team is planning February in Honesdale, 23rd. I'd have to look at the date again. Up in Honesdale, we're going to have a workshop, and the workshop is designed for schools that are interested in woody biomass boiler installations.
I have January 27th.
27th, okay.
I think I've heard rumors of it, but I'll send you an email, Michael, and hopefully I can get the details.
Okay, very good. And
yeah, I'm pretty sure it's the conservation district's hosting that.
That's right. Very much interested in having you and your friends attend that. Because we've had good success in years past with these workshops. It brought people together, opened that dialogue, and we're encouraging some of the vendors, the boiler manufacturers, to be there. AFS, AgriPower, Messersmith, have them present so that they can start showing school boards what kind of products they manufacture. So yeah, very much interested in having your attendance there.
Okay. Let me also pass on, I see Veronica asked a follow-up question to hers original question, which was, will then environmental and carbon emissions be significant enough reasons for hospitals to use biomass?
Would that be incentive enough? I would say that could be. I can't speak directly for them, but that is a very possible motivation for hospitals to look at their carbon footprint, or for universities to look at their carbon footprint and to realize that they can have a positive effect by installing a wood energy system. Bloomsburg University has a wood chip boiler, and that was one of their reasons. They wanted to improve their carbon footprint. They removed a coal-fired boiler to find a space to put in one of the wood chip boilers. So yes, I would say that is a very viable reason or incentive for some, like hospitals and universities, federal buildings like federal prisons. The Federal Energy Management Program is in place to encourage federally owned buildings, federally managed buildings, to look at their institutions' carbon footprint and how they can make positive improvements through the use of biomass. So.
Okay, I think we better wrap it up with that. And thanks to Mike again for taking time to come here and be with us and give us the presentation, and for the question and answer session.
Thanks for the invitation.